Okay, this is 2.7, part 3. Instead of using truth tables, we're going to analyze a deductive argument using common arguments. So this page, we'll see a chart here, and we're going to talk about which one's which. What you're going to do is write out the arguments symbolically and then match them up and see if it matches anything we have here. This chart, or this table, will be given to you. And when I say table, I mean, let me just show you what I'm talking about. This will be given to you on the test. Okay, so you don't have to memorize them. And in fact, when you do your homework, I would have this page out. So let's look at the common arguments. Direct reasoning. If P then Q, which is a conditional, is premises 1. Premises 2 is P, and the conclusion is Q. Contrapositive reasoning. If P then Q, which is a conditional, is premises 1, premises 2 is negation Q, and the conclusion is negation P. Disjunctive syllogism. So there's two different ones you can do. We do the disjunction, P or Q, for premises 1, the negation of P for premises 2, and the conclusion is Q. Or we can have P or Q, negation Q for premises 2, the conclusion is P. Transitive reasoning. Premises 1 is the conditional, if P then Q. Premises 2 is if Q then R. I hope you guys remember that is the converse. And the conclusion is if P then R. That is transitive reasoning. Fallacy of the converse. If P then Q is P1. Q is P2, therefore P is the conclusion. And fallacy of the inverse, if P then Q, negation P, therefore negation Q. Okay, so you might want to keep this page out while you're writing stuff because, again, we're just trying to match things up, okay? So write the argument symbolically, then use common arguments to determine whether the argument is valid. State your reasoning. It says, if I ignore my problems, then they go away. I ignore my problems, therefore my problems go away. Okay, so P is I ignore my problems. And Q is they go away. Okay, so let's do premises 1, which is the first statement. If I ignore my problems, P, then they go away, Q. So that is the conditional. So that's P1. Second sentence, P2. I ignore my problems. That's P. The conclusion is, therefore, my problems go away, which is Q. Okay, so I got to match that up. So if I look at the table, I see that direct reasoning says premises 1 is if P then Q, the conditional. Premises 2 is P, and the conclusion is Q. So this is direct reasoning. And since it's direct reasoning, this argument is valid. Okay, let's look at the next one. If you study sets, you will better understand logic. If you better understand logic, you will better understand probability. Therefore, if you study sets, then you will better understand probability. Okay, so there's three things going around here. P is you study sets. Q is you will better understand logic. And then we have a Q, or an R, excuse me. An R is you will better understand probability. Okay, so we have a P, Q, and R. So let's look at the first sentence and do P1. If you study sets, that's P, then you will better understand logic. That is Q. So this is P1. Let's look at P2. If you better understand logic, that is Q, then you will understand probability, which is R. And then we have the conclusion, because there's a therefore word. If you study sets, remember that was P, you will better understand logic. So if then, you better understand logic would be Q. Or sorry, I read that wrong. It says, therefore, if you study sets, you will better understand probability, which is that needs erased there. That is R, okay? So the conclusion is if P, then R. All right, so if I look at my table, I see that that matches up with transitive reasoning. If P, then Q, if Q, then R, therefore P, then R. So that is transitive, not attive, transitive reasoning. Therefore, this argument is valid. Okay. Write the argument symbolically, then use common arguments to determine whether the argument is valid. State your reasoning. All right, so Paul will eat pizza for lunch, or Daria will order delivery. Daria did not order delivery, therefore Paul ate pizza for lunch. Okay, so P, we're going to let this equal Paul will eat pizza for lunch. And Q is Daria will order delivery. Okay? All right, so we have those two things going on. Let's look at the first line, which is going to be P1. So premises 1 says Paul will eat pizza for lunch, which is P, or Daria will order delivery, which is Q. So P1 is the disjunctive P or Q. P2, which is the second sentence, says Daria did not order delivery. So that is the negation of Q. And then we come up with our conclusion, which is therefore Paul ate pizza for lunch. That's P. Okay, so let's see if that matches up anything. The only one that has the disjunctive is the disjunctive syllogism, which says P or Q, therefore Q, or excuse me, P or Q is P1, P2 is negation Q, therefore P. That matches up. So this is disjunctive syllogism. And this argument is therefore valid. So again, if they match up, then the argument's valid, okay? All right, I'm going to stop the video because I don't want it to be like too horribly long. So that was the part 3. So I'm going to pick up here and do a part 4. Okay. All right, guys, thanks for watching. Continue on.